So I'm going to go ahead and do videos for Module 20, even though you're not going to have any technical homework assignments with it. So in 19.3, we just looked at finding axis of symmetry in standard form. So this is a continuation of that, plus some other things. So this is one time I am going to use the explore problem and kind of fill in the blanks. So we have a standard form of a quadratic. One of the things you may want to do to kind of get used to this, is learning to label. So right here, underneath this, I'm going to put A is 1, B is -4, and C is -5. My A is my coefficient here, which is 1. There's my B, and then there's my C. So going through axis of symmetry, -b over 2a. So what is my b again? It is -4. 2 times a is 1. So I get -4, but you remember right here I have a negative of a negative. So really that becomes a positive. So I get 4 over 2, which is 2. So my axis of symmetry is at x equals 2. Now again, if this were in vertex form, that would be easy to see. So there's some advantages and disadvantages of both forms. Okay, now, how do you find the vertex? Well, now that I know x is 2, I know my axis of symmetry always goes through my vertex. Think about my vertex being here. My axis of symmetry goes right through the middle. So I know the value has to be 2 for x. So what I do, I plug 2 in here to all the x's, and then I simplify. So that's 4 minus 8 minus 5. And if I simplify that, 4 minus 8 is -4, minus 5 would be a -9. So my vertex now is at 2, -9. So now I found the vertex when it's not in vertex form. Now it says find the y-intercept. So here in just a second I'm going to show you a shortcut, but how does it ask you to find the y-intercept? The y-intercept is when x is 0. So what I do, I put 0 in here. And this is a -5 right here. So what is the y-intercept? Well, all this just goes away, and what do you get? You get -5. Now, this is important. What that means is whatever the value of c is our y-intercept. Now, think of that in context of a linear, y equals mx plus b. Whatever my constant is my y-intercept. Well, the same is true here with the quadratic. Y equals ax squared plus bx plus c. Whatever my constant is my y-intercept. So then it says find 2 more points on the same side of the axis of symmetry as the y-intercept. Okay, what does that mean? So our y-intercept's at 0, -5. So it wants when x is 1 and x is at -1. Those are 2 values on either side of it. So you plug -1 in here, or 1, sorry, and -1 in here. So if you plug 1 in, you simplify, 1 squared is 1. That's going to be -4. That's going to give you -8. And I should have known that, but anyway, we'll just keep going. -1 squared, remember parentheses here on negatives. -1 here, so that gives me +1. I'm going to go ahead and change this to plus, because a negative times a negative becomes a positive. So now I have a 0 here. So on either side of the y-intercept, I have these new point values. So then it says graph the axis of symmetry, the vertex, the y-intercept, then 2 extra points on the same coordinate plane. Then reflect the graph points over the axis of symmetry to create 3 more points. Okay, what does that exactly mean? So what we're going to do first is we're going to plot our vertex, which was at 2, -9. My axis of symmetry goes through that. I use a dotted line here. You can use a solid line. But that is the equation x equals 2, because that's where my vertex is. My y-intercept was at 0, -5, which would be right about there. Then my other 2 points I had were 1, -8, so right about there, and also -1, 0. Now, what we do here is we understand the idea of symmetry. Symmetry means that wherever there's a point on the left side, there's an identical point on the right side, given the distance away, okay? How do I explain that? The distance away from the axis of symmetry here is 1 unit. So I go directly to the right of the axis of symmetry 1 unit, and I put a reflected point. I do the same thing here. Here I'm 2 units away. So what do? I go 2 units away on the right side and put another point directly across. This is what we mean by symmetry. So here I'm 3 units away. So I go 3 units away here and put another point. And what that does, that allows me now to be able to draw my parabola. Think back to the equation itself. We knew that the A was a positive, therefore it should be opening up. So this kind of fits that. So continuing on, using zeros to solve quadratic equations graphically. Okay, what are zeros? Okay. I'm going to let you kind of look through the example that they do here. What I'm going to do is go on. I'm going to show you one from scratch. So I'm going to do the your term problem here. So what I'm trying to do here is find the zeros based on the equation. Now I'm going to do some things a little differently than the book does, and the book helps you tremendously on this, but what am I trying to do? What I'm wanting to do here is show you a couple ways to do this. First, if I want to find the zeros, one of the ways I can do this is to put it in a form to graph it, find where it crosses the x-axis. Why the x-axis? Because that's where y is equal to 0. That's what we mean by the zeros. And then I'm going to talk to you about how to do it on the calculator in some different ways. So one way to do this, let's get it equal to 0. So that cancels. So x squared minus 1 equals 0. Now, once it's equal to 0, what you can do is go in the calculator. Under y equals, type in your function, x squared minus 1. Then go to second trace, which is calculate, and one of the numbers there, I think number 2, is 0. Now, what you should do is when you pick that, the graph should come up. And when it graphs, it's going to show you where it crosses the x-axis. And that's where I'm going to kind of talk you through over here on the graph and how to use the calculator at the same time. So, what does this mean? Well, this is kind of vertex form. Think about it this way. I could rewrite this if I wanted to as y equals x minus 0 squared minus 1. So where is my vertex at? Shift to the right 0, go down 1 unit. That's all this is, a transformation down 1. So my vertex is at 0, -1. Then you draw the graph. Now on your calculator, what you have is the graph opening up. And when it opens up, it crosses the x-axis at 2 points. One here somewhere and one here. And when you do second trace, calculate number 2, I think it is again, 0, the first thing it's going to ask you is left bound. Okay? So what does that mean? Well, on your graph, when it's crossing, you've got to do this 2 different ways. Left bound for this one is here. Because why? It crosses the x-axis right here. So you've got to pick a point that's on the graph to the left of where it crosses. When you do that and press enter, it's going to ask you right bound. So then you pick a point here, and then it's going to say guess. Move your cursor close to where it crosses, press enter, and then it should give you a 0. The form is going to be like this, something 0. Well, on this left-hand side, what it should come up is -1, and I'll explain to you how I know that here in a second. Then you do second trace, calculate 0 again. This time you do left bound on the other side. Now, when you're looking for this one, you need to pick a point to the left of it. So that means I'm going to put my cursor somewhere here. then it's going to say right bound. Now I need to go up here. So you need to be on either side of the x-axis. This is to the left, that's to the right of where it crosses. Then it says guess, move your cursor close here, and then press enter, and then what is it going to come up? It's going to come up 1, 0. Now, how did I know that? Well, there's a couple ways to do this, and we're going to look at different ways to solve, but one of the things that you could do is take the equation itself, and instead of setting it equal to 0, think of it as x squared minus 1 equals 0, okay? And then add 1 to both sides. You do that, you get x squared equals 1. So you're asking yourself, what can I square, what number can I square to get 1? Well, there are two numbers. If you square -1, you get 1, and if you square 1, you get 1, which, in this case, end up being our zeros. Now, if you go back up to the example they did here, theirs is a little more complex. Why? Theirs is a little bit more complex because their equation wasn't so simple. You do standard form. If you move this over, that becomes a positive x squared plus 6x plus 8 now equals 0. So the related function is, just rewrite it, 0 is x squared plus 6x plus 8. It says make a table of values for the related function. Okay, so what do? You go to y equals and put that in, and then you go to your table and look at your values for the table. So if you look at the table on your calculator for the values, you can plug those in. When x is -5, you have 3. When x is -4, you have 0. Oops, it's a bad 0. Next is -3, you have -1. Then you have 0, and then you have 3. So what is this? That's my vertex, because that's where the pattern repeats. Here are my zeros that I can get from the table. Now here's the problem. It doesn't always happen. It depends on what the function is. And that's the reason I told you down here how you could find zeros using the calculate button on the calculator. You can also find it using points of intersection. So I'm going to do this one a little bit differently as well than the book does. Again, they give you a relatively good example, talk to you about how to graph it and find the intersection, and we've done intersection on the calculator. So that's another way you could do it. But what I'm going to do is I'm going to try to show you algebra how to do this as well. So I'm going to take the your turn problem here and try to show you how to do it using a little bit more algebra. So I have the equation 3 times x minus 2 squared minus 3 equals 0. So instead of getting it equal to 0, let's do this. So I do plus 3. So I have 3 times x minus 2 squared equals 3. And I divide by 3. So I have x minus 2 squared equals 1. Okay, so think about it this way. I need to be able to square a number to get 1. What do I square to get 1? Well, we said earlier you square -1 and 1. But this is not just x. This is x minus 2. So I need to think about what can I plug in for x to end up with -1. Well, I could put in a 1. So if x is 1, that's going to give me 1 minus 2, which is -1 squared, which gives me 1. What can I plug into x to get a positive 1? Well, I could plug in x is 3. If I do 3 minus 2, I get 1. 1 squared is 1. So that's another way to think of it. So graphically, I could go over here to where 1 is and put point where it crosses the x-axis and go to 3 and put a point where it crosses the x-axis. The other thing I could do is go ahead and plot my vertex. My vertex here is at 2, down 3. So I go to the right 2, down 3. There's my vertex. Now I have 3 points where I could almost go ahead and graph the function. Now again, you can use the calculator, or you can do the method of which the book shows you and find the point of intersection by moving the 3 over. So this one is create a quadratic function for each problem and then solve it by using a graphing calculator. So again, they give you some examples here, and what I'm going to do is go immediately to the your turn problem. An egg falls from a nest in a tree 25 feet off the ground and lands on a potted plant that is 20 feet below the nest. The function, so they give you a function, gives the height and feet of the egg as it drops, where t represents time. When will the egg land on the plant? Okay. An egg falls from a nest in a tree 25 feet off the ground and lands on a potted plant that is 20 feet below the nest. Okay, that's important. 20 feet below the nest. So if it's below the nest, so again, 20 feet below the nest, that means it's where? It's actually 5 feet above the ground, because the nest was 25 feet off the ground and the potted plant is 20 feet below the nest. So that means it's 5 feet off the ground. Now, why that's important is because when we're looking for this, when it lands on the plant, we are setting this equation equal to 5. The reason is because, again, the nest was 25 feet off the ground, the plant's 20 feet below that, so it's equal to 5. Now, in terms of solving, you can set it equal to 0, put it in your calculator and find the zeros, or you could have taken this one, set it equal to 5, and done y1 for this function, y2 for this one, and found their point of intersection. Now, when you do that, you're going to get two answers. And what we need to understand is the context of this problem. Remember, our x, or our t here, represents time. So if you find the intersection or you find the zeros, one of those is a negative. And negative is not applicable here because we are not using negative time. So all we're doing is trying to calculate the positive one. So if you find the positive one, you should get approximately 1.12, and then t was represented in seconds. Now, there was another answer, which was the negative one, but again, the negative is not applicable in this problem because you can't have a negative time. But if you did find the negative 0, you got negative 1.12. Okay, but again, that doesn't apply because you can't have negative time.